Hello, and welcome to my demonstration on how guitar pickups use electromagnetic principles to capture the sound of a guitar strings. In this video, I'll build a guitar pickup from scratch and explain how Faraday's law of induction combined with ferromagnetic properties capture the sound of an electric guitar. So let's start with how a pickup works. Inside each pickup is a magnet that creates a magnetic field kind of like this. But since the strings are made of steel and nickel, which are ferromagnetic, the field looks a little bit more like this. Now, every time the strings vibrate, they create a change in magnetic flux. And we know from Faraday's law that a time rate of change of magnetic flux will create a voltage in the coils that are inside that magnetic field. Finally, if we feed that voltage into a guitar amp, we'll get a great electric guitar sound. So now let's see how this pickup is made. I start by cutting off 2 pieces of a wooden yardstick, and I'm going to use that as the body of my pickup. The next step is to drill 6 holes that line up with the guitar string spacing. I taped both pieces of my yardstick together so that when I drill through, the holes perfectly line up with each other. You'll see why that's important in a second. I then threaded 6 machine screws through the holes that I just drilled. I backed off the screws and spread out the plates to create the body of our pickup. So winding the magnet wire around the pickup was by far the hardest part of this entire project. I made a setup where the wire was able to freely rotate around a post attached to my clamp. I then hot glued a bolt to my pickup so I could then put it in the chuck of my drill. To make connecting the ends of this pickup coil to my amp easier, I created 2 posts with M6 bolts and nuts. I used rare earth magnets for my pickup because they were small enough to fit on the bottom, but also they have a strong enough magnetic field that it'll pick up the vibration of the string. I secured the magnets down with hot glue because they often wanted to connect to the magnet next to it. It also made it so it was easy to add more magnets later on. To test my pickup, I hooked up the ends to my multimeter and put the multimeter on millivolts. I waved a magnet in front of the screws to try to induce a voltage. I started with a magnet because I figured it would induce a larger voltage and be more obvious if it was working or not. So clearly the magnet can induce a small amount of voltage, so I needed to move on to just a plain steel screw. I waved this in front of the pickup and didn't get quite as much voltage as the magnet, but I was still able to pick up a couple millivolts of induced voltage. The final step was to cut off the end of my guitar cord and take the loose wires and attach them to the electrical posts. I also added another row of magnets as part of an experiment where I wanted to see how a stronger magnetic field would affect the induced voltage. Okay, so we are ready for the initial test. I've kind of hooked up my pickup to line up with my guitar strings. My setup is that I have my amp over here and my cord that I've spliced to fit onto this guitar pickup, and let's go and see if it makes any noise. So that sounds like we're getting a pretty good sound. There's a little bit of crackling and everything. I think that would have to do with the fact that it's not very insulated. You're probably getting some outside noise, but I would call that a successful first test. Alright, so this time I've hooked it up to my ukulele instead of my guitar, and the real big difference here is that the strings aren't made of a ferromagnetic material. These strings are made of nylon, so they shouldn't theoretically make any sound with my pickup. Same setup, I have it hooked up to my amp again, so let's try this out. It doesn't sound like anything's coming from the amp. Ukulele in and of itself, it's got that sound hole to make it louder, but I would say that proves the point that you need a ferromagnetic material to disrupt the magnetic field of the pickup to pick up any noise.